Okay guys, I'm here early this morning. I'm going to try to record some videos for you so that you can review while I'm out. But anyway, so what I'm going to require you guys to do is, let's say 4 through, this is page 374. Let's go numbers 4 all the way through, I want to get some logs in there. So let's say 34. 4 through 34, that should be easy enough. 4 through number 34, all the evens. I'm going to go through the odds. So before starting this video, what we're talking about, before getting too far into it and just working problems, is we're going to be talking about transformations, something that's very familiar to you guys already, but we're doing it with logarithms and exponential functions, which it's not really much different than anything else. It's just an unknown function. You guys aren't used to this. So what I want to start off by doing is explaining an exponential function and how it's always going to go through the same few points. So let's say I have 2 to the x. Okay, so it's going to have this asymptote right here at 0 because 2 to the 0 power is going to be 1 right here. So when x is 0, it's always going to go through the point 0, 1, always. And as x gets to negative infinity, as it approaches negative infinity, you're just getting a really, really small fraction. So it's never actually going negative. Okay, now you can take this and you can slide it down by putting like a -1 out here, and it would slide the whole graph down 1, so it would cross the x-axis. But generally speaking, your basic exponential functions should never cross the x-axis. Let me do a few more. So let's see. If I have 10 to the x power, it's still going through the same points. Notice it goes through 0, 1, because 10 to the 0 power is still 1. But look how steep it is, right? So all that's changing is the steepness. I could even make it more steep if I wanted to do maybe like 50 to the x power. So they're all going through the same point. That's even more steep. Or I can make it flatter, potentially, by doing like, 1.1. Oops. Let's do 1.1 to the x power. So that's very flat, still going through the same point, notice. But now I want to show you something. What happens if what I'm exponentiating, like what if what's multiplying by itself over and over and over is a fraction? So notice I did 1.1 because I knew at 1 it's going to be a flat line. So let me show you that. 1 to the x power. That's just a flat line because you're doing 1 times 1 times 1 times 1 times 1, and that doesn't change. Let me get rid of all of this real quick. Okay, now let me start looking at some decreasing models. So 0.75 to the x power. This is decay. Okay, still going through the same point, but as you multiply 0.75 times itself over and over and over and over, it's getting smaller and smaller and smaller. Okay, so it kind of flips it. Let's do something even smaller, 0.01. No, that's too small. I don't think we're even going to be able to see that. Let's just say 0.2 to the x power. Okay, so that's even steeper, right? That's the same as like 5 to the x power, except it's the complete inverse, pretty much. So you can see it's just steep. If you have a decimal value in here, right, that's being multiplied by itself, then it's going to be decay, exponential decay. If it's bigger than 1, it's going to be exponential growth. So before we actually get it started, I wanted to point some of that stuff out. But other than that, everything is based on that the fact that all of these are going through the point 0, 1, and they all have an asymptote right here at y equals 0. So as it approaches y equals 0, x starts going out to negative or positive infinity. Outside of that, transformations, nothing else is really that necessary to know. Just transformations, very basic. So let's look at some of these now. I'll go ahead and do 3 and 5. You guys can match up 4 and 6. It's easy enough. But anyway, knowing that this function initially went through 0, 1, and also remember the base tells you the second point it would go through, which is 1, 2. Okay? But knowing that, let's just go with 0, 1. If it went through 0, 1, 0, 1, right here, and then it got shifted. Let's see how it shifted. It says +2 up here where the X is. You guys probably can't see that on the video, but if you're looking at your book right now, you can. It says +2, so that means it shifts left 2, and then that -2 on the end would be down 2. So if I take this point and I go left 2, down 2, that would put me at -2, -1. So which one of these goes through -2, -1? -2, -1. Right there. That's the only one that would match up. So C is number 3. This one goes through the same point. It should, at least. It should go through 0, 1. So, I mean, it would have. Let's say it that way. So, again, if it went through 0, 1, I mean, it should have the original, but then got shifted right 2 because it says -2 in there, and then down 2. So right 2, down 2. It should be going through that point right there. So 0, 1, right 2, down 2, not that one. 0, 1, right 2, down 2, not this one. So this is the only one that goes through this point. So that's going to be letter A. 5 is letter A. You guys can match up 4 and 6 the same way. So notice, again, one more time, let me recap. What I'm referencing is that point 0, 1, and then I'm shifting from there. Okay, so let's see. Describe the transformation of f represented by g, then graph each function. So you can just do real junky graphs. Here, I'll give you an example of a graph that I'd be okay with. So it says, describe the transformation of f represented by g, then graph each function. Okay, so right here, it has f of x is 3 to the x, and then g of x is 3 to the x plus 5. So here's f of x right there, and then you're just adding 5. You're shifting the whole thing up 5. So if I was going to describe the transformation, I'd say maybe shift up, or I could say vertical transformation of up 5, like that. That would be fine as far as the description. Now the graph, I would just do something like this. Knowing that it originally went through this. This is what f of x would have looked like, something like that. And there's the point 0, 1. Then I'm okay right now for you guys just to transform it by going up 5 from there. So let me go ahead and erase this. So if it went through 0, 1, and I go up 5, now it's going to go through 0, 6. Something like that. And then realize there's that asymptote right there. So that would work for me. So that's number 7. Number 9, it says e to the x. And then it says right here, this one's e to the x and then -1. So it's down 1. So if my original e to the x was like this, asymptote here, e to the x, like that, went through 0, 1, now drop it down 1. Okay? So here's my new asymptote. And now my point should be going through 0, 0, something like that. Okay, so I just dropped that down 1. Okay, let's see. Number 11, it says 2 to the x, and it gets, and then just transformation of f of x to g to x is just right 7. So it's 2 to the x minus 7. So if 2 to the x originally, again, went through the point 0, 1, like that, is where it originally was. I had an asymptote right here at y equals 0. If that was the original function of f of x, now shift that whole thing right 7. So now instead of going through the point 0, 1, I'm going to go through the point 7, 1. So it's just right 7. So if this was 0, 1, now that's 7, 1. Looks very similar. It even has the same asymptote. Okay, the whole function was just shifted right 7. All right, let's keep going with this. And the reason I'm going so fast, guys, is I want to record a few videos this morning just to help you guys out. And also, I remember you saying just working through a lot of problems was most helpful. So I'll just keep going with this. E to the x, and then this one says negative e to the x. So if e to the x normally looks like 0, 1, like that, okay, negative e to the x would just reflect that point. So here's e to the x, asymptote was here. Negative e to the x would take all my y values and make them negative. So it would be at 0, negative 1. So it would be down here. just a reflection over the x-axis. Okay, so that would be number 13. Okay, let's keep going with this. Number 13, number 15. Okay, so this says 1/4. It's an exponential with a base of 1/4, which means, guys, that it's exponential decay. It still goes through the point 0, 1. Okay, but it's of degree 1/4. So looks something like that. Okay, exponential decay. But I'm going to shift that exponential decay now. I'm going to go ahead and do it just on a separate graph. I'm going to go, because it says x minus 3, I'm going to go right 3, and because it says plus 12, I'm going to go up 12. So if it went through 0, 1, if it had gone through 0, 1, then I want to go right 3. So now it's going to be 3, 1, and up 12. So it's going to be, here's right 3, 3, 1, and then up 12. So it's going to be 3, 13. So this is just an estimation. Probably not a very accurate one. But the concept still remains. All right, so there's going to be the point that it starts going through now, and it's still exponential decay. It still has its same shape. It's still an exponential with the base of 1/4. So the shape remains. It just shifts up, down, left, or right. Okay, there's that one. Let's see. Describe the transformation of f represented by g, then graph each function. So notice, here's an exponential with a base 10. This is base 10 also, but now it's stretched by a factor of 2. Notice my base is not 20. You first raise 10 to the x power, and then you multiply by 2. Okay? So my base is 10, stretched by a factor of 2 though. So if my original was very steep, still going through the point 1, 0. So remember, x to the 10 10 to the x is very, very steep. So it's that. Now it's stretched by a factor of 2. So all those points in there actually get doubled. So if I was going to be really accurate, let me go ahead and be really accurate on this one, or more accurate. So this goes through normally 0, 1. It also goes through, 1, 10. So when x is 1, y is 10. Okay? So if I'm doubling that, then when x is 1, y is 20. All right, so let's go ahead and graph that one in, let's just go black. Let me go back on that. That was a mistake, and I don't know how to go back very well on this board right here. Let me just regraph this real quick. Okay, so this was going through 0, 1, like that. The next one would be going through, I'm doubling my y values, so it'd be actually 0, 2. And then it would also pass through 1, 20. It's twice as steep. And that's what it would mean to be stretched by a factor of 2 right there. Okay, I know that looks probably like a terrible graph, but it is what it is. If you go back, you listen to what I'm saying, the concepts still remain there. Okay, this one, notice it's base 2, so that means this 3 out front is a stretch factor, stretched by a factor of 3, and it's also shifted right 3. So my original graph would look something like this, and it would go through the point 0, 1, and it would also go through the point, because it's base 2, it would go through the point 1, 2, just to get some specifics on there. All right, so my new graph, okay, would be stretched by a factor of 3 and also shifted right 3. So let's go ahead and go right 3 first. So instead of going through 0, 1, it's going through 3, 1. All right, 3, 1. And instead of going through 1, 2, it's going through a point called 4, 2. It's going through the point 4, 2. Like that. And then also keep in mind that it's stretched by a factor of 3. So instead of going through 3, 1, my y values are 3 times as big. So it's actually 3, 3. And instead of going through 4, 2, my y values are 3 times as big, so it's 4, 6. So 3, 3, 3, 3, 4, I'm just estimating, 6. Might look something like that. Or very close to it, I would say. Okay? Guys, as far as the stretch factors and stuff are concerned, I'm not going to be very stickler on that. I mean, I know all these you can just type into your calculator and find out how to graph them anyway. So I'm just making sure you understand the basics of a stretch factor, not exact, but you know that that should be 6 times as tall. Okay, so it's stretched 6 times the amount. This means shift left 5. This means shift down 2. Again, you can see all of that if you type it into your calculator. I'm going to go ahead and stop this video here, and that will be the video for transformations.